Hi students, in this video we are going to discuss some important points. Hi students, in this video we are going to discuss about some important points. Point number 1. Point number 1. A coin placed a coin placed a coin placed at the bottom of a container. At the bottom of a container appear to be raised. Appears to be raised. Appears to be raised when the container is when the container is filled when the container is filled slowly with water. Slowly with water. Now, there is a one formula. Therefore, we can show that N W A is equal real depth whole by apparent depth. Its value is 4/3. Therefore, apparent depth. So once again, apparent depth is equal 3/4 into real depth. Now I would like to draw a diagram for this one. That means take a water can or container. Here there is a water. It is the water. Here there is a coin. It is a coin. From here to here, our eye is here. Now, from here to here, this is real depth. Now, but the coin is appears here. Look like appears here. The coin is look like appears here. That means from here to here we can call as apparent depth. Apparent depth. Therefore, apparent depth apparent depth is equal to 3 by 4 into real depth. Therefore, apparent depth is equal to 3 by 4 into real depth. This is the formula. Now, come to the second point. A glass slab appear to be a glass slab appears to be less thicker than less thick than it actually is. Now, once again, a glass slab appear to be less thick than it actually appear is. This is another important point. That means take a glass slab, it will be look like as a less thicker, but actually it is more thicker. This point support that explanation. Now, point number 3. Point number 3. An ink dot marked on a paper to be raised. When viewed through a glass slab. Once again, I am explaining this point. An ink dot marked on a paper to be raised when viewed through a glass slab. That means here this is a glass slab. Here there is a paper. It is a paper. Here there is a one ink mark. This ink mark actually gives us some certain height. But whenever we are keeping the glass slab on that one, it will be look like raised. That means this point supports this diagram. Please draw this diagram also. Now, point number 4. Point number 4. Absolute refractive index absolute refractive index absolute refractive index of a medium n is equal speed of light in air to the speed of light in medium. Once again, I am repeating this point. Absolute refractive index of a medium, that implies n, which is denoted by n. Therefore, n is equal speed of light in air to the speed of light in vacuum. Once again, absolute refractive index of the medium, which is denoted by the n. Therefore, n is equal speed of light in air to the speed of light in vacuum. That means n is equal to C by V, where C, V are in meter per second. Therefore, n has no units. N has no units. This is the point we have to remember. Now, point number 5. Now we are going to discuss about point number 5. Relative refractive index of relative refractive index of medium 2 with respect to medium 1 is given by n 2 1, that is equal n2 by n1, that is equal v1 by v2. Once again, the fifth point I am repeating, my dear students. Relative refractive index of medium 2 with respect to medium 1 is given by n21 is equal n2 by n1, that is equal v1 by v2. Now we are going to discuss about point number 6. However, please observe carefully. n12 is equal n2 by n1. But we know that refractive index is always inversely proportional to the velocity. If n2 by n1, that is equal obviously v1 by v2, because both are inversely proportional. Okay? Here v1 comma v2 are in meter per second, and also N2, comma, N1. N1 have no units. No units. And another formula. Point number 6. N2, 1 is equal to 1 by N1, 2. Once again, I am repeating the point number 6. N21 is equal to 1 by N12. Next, point number 7. Snell's law of refraction. Snell's law of refraction. When light travels from medium 1 to medium 2, then N2 1 is equal to N2 by N1 is equal to V1 by V2 is equal to sin I by sin R. Once again, I am repeating this point, my dear students. Snell's law of refraction. When light travels from medium 1 to medium 2, then N21 is equal to N2 by N1. That is equal to V1 by V2. That is equal to sin I by sin R. This is the formula we have to remember. Now, we are going to discuss next point. Point number 8. Refractive index, that is equal to N, is inversely proportional to, that means refractive index inversely proportional to 1 by light velocity, or N is inversely proportional to 1 by C. This is the point we have to remember. That means refractive index is equal to 1 by light velocity. Okay, next point number 9. NWA, that means refractive index of water with respect to the air is equal to, what is the formula? Real depth which is denoted by x whole by apparent depth. Apparent depth which is denoted by y. Therefore, refractive index of water with respect to the air is equal to x by y formula. This is also one of the important formula. Now, I draw a diagram to make you understand easily. Now consider this is a water container. Here there is a coin. Consider its height is from the tank x called as real depth. But actually, whenever we are observing here, the coin is look like migrated upward direction. That means from here to here, we can consider as Y. Y. From here to here, we can consider as Y. This is real depth. This is apparent depth. Therefore, refractive index of water with respect to the air is equal to real depth x by apparent depth y. That is equal to real depth by apparent depth. Apparent depth. My dear students, this point we have to remember. This is very, very important. Now, next point. Velocity of light in air/vacuum is given by, that is 3 into 10 to the power of 8 meter per second. This is the standard value we have to remember. In this video, we discussed 10 important points. Please remember that points so that we can do best numericals in this chapter. Thank you very much for watching this video.